Access control, DACL, and Windows. Access control is a security technique that regulates who or what can view or use resources in a computing environment. There are three types of access control mechanisms. DAC, discretionary access control, where the owner of a resource decides who has access. MAC, mandatory access control, where the administrator manages access controls. RBAC, role-based access control, where access control is specified according to roles. In the case of Windows, we use DACL, discretionary access control. Here, each file will have an access control list that maps users with their denied or allowed permissions. Each user is identified by a token that either maps to an individual or a group of users. Let's take an example. Here, we want to grant read and write permissions to Vivek. The access token of Vivek, along with the DACL, discretionary access control list, is given. To solve this problem, we need the Windows access control algorithm. Now, let us have a look at the Windows access control algorithm. Here, P is the set of permissions we need, and G is the set of permissions granted so far. Initially, G is an empty set, and P in this case is the set read and write. Now, we pass through each entry in the DACL specified by the for loop. Two conditions are checked: whether the SID of the access control entry matches the SID of user, and two, whether permission is required by the user. Once these two conditions are satisfied, the algorithm checks whether the permission is allowed or not. If it is allowed, the permission is added to G. If it is denied, the passing quits and access is denied, and the passing continues until it reaches the end of the DACL or until G is equal to P. Coming back to the question, initially P is a set read and write, and G is an empty set. Taking the first access control entry, we see that SID of ACE1 matches the group SID of Vivek, but the access permission execute is not required by us. So this entry is discarded. Taking the second ACE, we see that SID of ACE2 also matches the group SID of Vivek, and the access permission read write is also required by us. This type is allowed, and hence these two are added to G. Now that G and P are equal, we no longer require to pass the remaining entries, and the algorithm quits, and hence the algorithm is completed.